All right, so we're going to learn about, there's several clauses that you write when you're going to make a SQL command. And we talked about these the other day. I'll just quickly write them down. There's the select, there's the from, the where, there's the group by, the having, the order by. That's good for now. There are others, but those are the main ones that you'll do. And you'll probably, as a database person, use those 6 clauses all the time, okay? Generally speaking, first of all, this is the order they must be written in, okay? Generally speaking, that also happens to be the order of frequency. In other words, you'll write the word select more than you'll write the word from. You'll probably write the word select and from more than you write the word where, kind of, and so on down the line. Order by is probably the only exception to that. You will write a lot more order bys probably than you will groups. We'll get to these guys another day, but today we were talking about this clause, the where clause. And in my book, it is named the Great and Powerful Clause. It's a little Wizard of Oz homage there, the Great and Powerful Oz. Okay, the Great and Powerful Clause, because this clause determines everything. It determines which records you're pulling out, how many of them you're pulling out, all kinds of different things, right? Okay, so we're going to be focusing on that today. Before we do, there's a couple other little pieces I want to show you, though, that you can do in your select statement, okay? So let's go ahead and get to the command line here, and we're going to use the TAL database, and I'm going to go ahead and start a file here that I can write my queries in. Save this as temp.sql. All right, and did I show you guys the T file? I did not, did I? Okay. All right, let me show you that first. I'm going to do it quickly. I would recommend, if you're not on a PC, by the way, don't even attempt to follow along because it's different on a PC, on a non-PC. I'm going to show you just conceptually what it is, and then later you're going to have to be required to turn in some assignments the way that I'm about to show you. But don't worry because the instructions for doing it will be in the assignment. But let me just show you basically what a T file is. And I wish I had a way to draw on my screen, but I don't know that I do. But so imagine in fact, let me see if I can find this for you online here. A plumbing T, what do they call that? Is it just a T? T-joint, yeah, I guess that's what it is. And yeah, there we go. Perfect. Okay, perfect. So look at something like this picture, one of these guys, right? Okay, we'll go with that one. That's a pretty one. So that's a T-joint, right? Now, what does this have to do with anything? Okay, imagine that when you type something on a computer or the computer is going to output something, anything, it has normally one place it goes. So imagine that output as a pipe. It's something inside of a pipe, water in a pipe. Where does the output normally go on your computer? To your screen, right? To your monitor. Where could it go, though? Could go to a file. It could go to a printer, right? It could go to all kinds of different things. So normally, though, the default, and this is the thing that's common with all computer systems, all operating systems, the default output, system output is the monitor, okay? What a T command will do will split the output. It'll make it go to 2 different places. So imagine that the output is coming into the pipe right here, and then it's going to come out over here, and it's going to come out over here. Over here is the screen, and over here is another place, which in our case is going to be a file. Okay, so output's going to come in here, and then we're going to split it off into a file and to our screen, so it goes to both places. Okay, that's the basic idea of a T file, or a T command. All right, so here's what that looks like. On the command line, you type the word T, and then you type the path of the file that you want to create to have the output go to. So that path for me is users jstone54 desktop, and then I'm just going to call it, output or something like that, .txt. And now it says I'm logging to the file, whatever, that I just wrote. So now, if I say show databases, remember kind of what the output's looking like here, right? Show tables, because I'm already in the TAL database. select star from customer, whatever, some hideous output there. And then I exit out. This file on my desktop's been created right here, this output file. If I go in there and look at it, it's literally everything I just did. It's my command where it said show databases. It's actually the output where it showed it. Show tables, it's the output. Here's the customer output. By the way, you can shrink it up and actually get a decent view of the customer table there. So all of that stuff happened because I created a T file. Now, when I exit out of my SQL, the logging stops. And then if I log back in and I run that same command again, T whatever file path, it will overwrite this file right here. Okay, so if I go back in here, my SQL, and I run that again, C:users, JStone54, desktop, and output text, and then I say use towel and select star from rep, just something quick. Oops, exit. Okay, now if I look at this file, oh, my mistake, it appends. Nice. I didn't realize it appended. For some reason, I thought it overwrote it. I wonder if it's because it was open. Let's try that one more time. Okay, so I'm going to close. I've closed the file now. And one more time. T C /users. Just stoner. A little flashback of my nickname in high school. Not for any reason that you're probably thinking, by the way. Wasn't that kind of guy. Maybe. All right, let's use Solaris this time. And show tables and exit. All right, so let's see now if I open this guy up. Yeah, it looks like it appends. Nice. Okay, so that's good news and bad news. You're going to be required to submit some of your assignments in the future. I've written out nice, clean, clear documentation on how to do this for a PC, which you just saw, how to do it for a Mac, and how to do it for a Linux machine. So that should cover everybody in the classroom. But the assignment will say, step 1, create a T file. Here's how to do it, right? And it'll show you for each operating system very clearly. And then you'll run a bunch of commands once the T file's been created, and then you'll submit the T file as your submission for your assignment. We don't have any of those right now, but probably next week you'll have some like that, okay? So I just wanted to kind of give you a little feel for what it's like while we got the recorder on. All right, and I don't know why I forgot that it appends. I guess I normally overwrite it. And so the reason, I'll get you in a second, the reason I want to mention now that we know it appends, be careful, because I don't want you to create a file for one assignment and then append the second assignment onto it, right? So now this file keeps growing. So make sure you make a new file for each assignment. And I usually tell you what name I want you to give the assignment, the file, right? Yeah, Jesse?
Just to give us a good time frame, when are all like the fields, when are we gonna have all like the fields and stuff?
Sunday. This week, yeah, this Sunday, yeah. And I'll be putting that assignment live probably tonight. Yep. All right. Any other questions about that? I wanted to make sure we covered that first, and then we'll dive in. I'm not going to be recording in an output file or in a T file, so I'm just going to delete that. Get back in the command line. Okay, so as we saw a second ago, in the towel database, select star from customer. It's pretty ugly, right? That's some pretty hideous output. And there are things I can do to adjust my command line so that the font's a little bit smaller or whatever. But we could actually write a query that cleans this up a little bit and still shows us all the data, okay? So what if I wanted to say, let's just take the city, street, state, and zip code and put them all as sort of one combined thing like you would see written on an envelope or whatever, right? Okay, so let's take a look at how that might look. Let's go, and this has nothing to do with the where clause just yet, but this is what's called concatenation, okay? Anybody know what that word means? Concatenation just means, it's a fancy word for sticking things together, putting stuff together, right? So there's actually a function in MySQL called concat. So it would look something like this. Select then when I say concat, and I'm gonna start off by showing you this in the rep table, so I can give you a smaller example, and then we'll do a bigger one with the customer table. So concat, and then from rep, okay? What goes in here is a comma-separated list of all the things you want to concatenate together, okay? So for example, I want, in the rep table, I want to do first name, comma, last name, all right? Now, this output has a small problem we'll talk about in a second, but this is how you would do this, right? So I'm going to go in here and paste this, and this is what it gives me. It actually gives me Rafael Campos, Megan Grady. It gives me their names. Now, what's the problem with that, my output there? No spaces, right? Also, the name of the field is this, right? That's not a good name. Okay, so we can clean up both of those. First of all, let's deal with the spaces. Well, if this is a comma-separated values list of everything I want to concatenate together, how can I easily solve that problem? Yeah, just comma, put a space in there. Now it's a list of 3 things I want to concatenate together. I want to concatenate first name with a space with last name. Okay, so let's try that one. There it is. And that looks a little bit nicer. But again, notice that ugly field name, right? Okay, we can actually rename that field name. We can give it, and now let me be clear. All the stuff we're doing here does not change the table, right? This is just us creating a display on our screen of what's in the table. It does not alter the table. You cannot alter a table with the select command. Select commands only display information. And this is just us customizing how that displayed information looks, okay? So if I wanted to rename this field here, this display field, I can actually, at the end of it, so I'm gonna put the from down below. At the end of it, I can say, this whole thing concat blah, 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 whatever, as name. Okay? Now if I run this, it says name, and there's the name. Okay? Now, another thing you might see that's a common way to do this is we do last name, comma, first, right? Last name, comma, first. Well, in order to do that, what do I want to do? I want to concatenate a comma in there, right? So I'll just stick a comma in those quotes. That looks a little confusing at first, right? Because you had all these weird commas in here. But it's the last name concatenated onto a comma and concatenated with a first name. Okay? Run that. And there we go. Campos, comma, Rafael, so on and so forth. All right, any questions about that basic idea? Okay, let's look at a bigger, messy one with the customer table. So I'm going to start off with select concat, and whatever I'm going to put in there, it's going to be the address, so I'm just going to call it as address from customer, okay? Well, what do I want to put in there? I want the address, so it was street, comma, space, city, comma, comma, right? Because usually you have city, comma, state, right? And then state, and space, postal code. Okay, that makes sense? So we're just concatenating each one of those on there. Everything between the commas is being concatenated together. So we start with the street, stick in there a space, then the city, then we put a comma, then the state, then a space, then the zip code, okay? And we're calling that whole thing address. So let's go ahead and run that. Whoops. All right, give me the command line. There we go. Get rid of that. Okay. And, oh, I said contact, and I meant to say concat. Concat. There we go. And there we go. Now we have the address all grouped together there, right? Well, we also want the other fields in our query, right? We don't just want only the address. So let's just describe customer. So we want the customer num, customer name. So let's just stick those in there, right? So customer num, customer name, And then we'll go with the address, which is all this crap. And then, oops. And then we want the balance, and credit limit and rep number. Credit limit and rep num. Okay? So there, that's, and by the way, this is typically how I write queries, is like, whoa, not like that. Like this. I'll do the select and then all the fields indented over. And then later, when we learn how to select from multiple tables at the same time, you'll see my from clause will also be that same way, and my where clause will do the same way. So you can quickly see on the first level, select, from, where, and whatever, and then everything else is indented. Okay? But this now gives us the whole customer table, but it cleans up this ugly display of this right here to look a little bit nicer, like that. Okay? And that's still not enough space, right? Still, this is a big display, okay? But this is nice to have it all in one spot here, okay? All right, so does that make sense though, concatenating? Yeah, Jesse?
So is that something you can write in your code to make sure that, like, say you want to print off an invoice for a customer, is that something you can write in your code to make sure the address is always in that format instead of broken?
Yeah, so if you're printing off an invoice, yeah, that is a type of query you would write to do that. But the real answer is typically the way that works depends on how you're printing the invoice. If you're using some software like QuickBooks or whatever, then you're not even really in the database. But if it's a custom thing that you built, typically the way I've done this is it's PHP, this is a programming language, and the PHP, I'll write a query in PHP that ties right into the database, pulls out the data, and then in PHP, I'll format it the way I want it to look. Saying it?
Just like overwriting two streams Java?
Nothing like that, actually. No, nothing like that. No, just, it's me just literally, yeah, okay, I see what you're saying conceptually, right? But PHP is a whole completely different, yeah. But it's not even, I would separate those in my head if I were you, yeah. So, no, it's me writing very specific code that displays, like, formats a whole invoice and everything, right? And oftentimes you'll tie in with like a PDF generator, so you can generate a PDF that looks like the invoice that you want. Okay. Yeah. All right. But this, yeah, that's a good use case of where you would do something like this, is when you're printing out something for the customer or whatever. But also a report for the boss, right? Maybe the boss wants to know just the customer name and the credit limits of all the customers, right? And so this is the report you might run for the boss, something like that, okay? And you don't need to have this big ugly display of an address like we had way up here, right? We could just do a simple one that makes sense for the quote layperson who's not a programmer, right? The boss, okay? And so this is the kind of thing you do all the time. Now, obviously, you would, if you have a good system, you would write this query once, and then you would save it, right? And maybe you have some code that runs it that lets the boss just click the button and it displays it for the boss or whatever, right? But that's the basic idea.
Like a procedure kind of?
No, well, you could do that too, a stored procedure. But what I'm talking about is I would have, again, a PHP web thing that they log into, and they click this button and it runs this query, right? And so they have sort of a little dashboard that they log into every day to look at a bunch of reports and stuff, right? All right. So next thing I want to look at is you can actually do math with MySQL. This is cool. All right. So if you'll remember, like on one of the first days when we first learned about these tables, we had you guys at the whiteboards figuring out how much money people owed us or whatever, right? And how we did that by subtracting the balance from the credit limit or whatever. Well, that's something that may be a useful report for the powers that be to know. And so what I can do here is, rather than showing the balance and the credit limit, I could actually show the credit limit minus the balance, right? And so I can do, let's get rid of the rep num, and let's add a new display here that is credit limit minus balance. I'm gonna put that whole thing in parentheses. And then I'm gonna call that as, amount due or something like that, amount due, I don't know. So this will add a third calculated, or a new column that's a calculated value. Just in our select statement, again, this is not altering the table at all. So now if I run that, and there we go, we show their name, their address, their balance, their credit limit, and how much they actually owe us. This guy owes us $6,200, right? This guy only we owe him $25, right? Okay? So again, that's just doing math, right? And I can do all the math that you're probably thinking you can do. I could do, now I'm about to change this to something else, which won't make sense, but as long as you understand that you can do any kind of math. So I can do addition, division, multiplication, can even do modulus, okay? So who's not know what modulus is? It's okay, most if you don't. Everybody? Okay, 1, 2, okay, good. So let me show you basically the idea of that. Let me change that back to minus here. Modulus is a really simple idea. Where it becomes tricky is learning how to use it properly. But the idea is very simple. So if I were to ask you basic math question, forget about computers and all that. If I were to say, what's 5 divided by 3? Let's go 5 divided by 4. What's the answer to that? Just regular plain old grade school math, Mylan.
1 1/4?
1 1/5, right? No, you're,
1 1/4.
yes, you're right, 1 1/4, I apologize, you're right, yeah. I was looking at I was thinking of this thing, you guys remember this? I don't know if I can draw it on here, let's see. Wait, at the end here. This thing, you guys remember that? Right, where you divide that way? And so I was looking, and so that should be a space there, like that. And so I was looking at it that way, which is actually not how you would write that. I would actually, if I were writing that above equation, it'd be 4 divided by, it'd be 5 divided by 4. So I was imagining that, that's why I said 1/5, because if I wrote it the other way, it would be 1/5. Anyway, get out of my head, okay? So you're right, 1 1/4, okay? It'd be 1.25. Now, in integer math, so James, in integer math, what would that be? Do you know? If I said 5 divided by 4, what would that be in integer math? Just 1, yeah. So in integer math, we truncate the decimal. So 5 divided by 4 is 1, okay? All right, so in regular math, it's 1 with a remainder of 1. That's regular math. Integer math, it's just 1. Modulus is this. If I say 5 modulus 4, what I'm really saying is what's the remainder of 5 divided by 4? That's all I'm saying. So in this particular scenario, both 5 divided by 4 and 5 modulus 4 are the same. So let's try a different one. 5 modulus 2 and 5 divided by 2. So this would be a 2 with a remainder of 1. And in integer math, it would just be 2. And 5 modulus 2 would actually just still return a 1. Okay? Because it's returning the remainder of that division right there. So anytime you see 5 modulus 2, what you're really saying is what's 5 divided by 2? Don't give me the number, but give me the remainder. That's what modulus is, okay? We're not gonna spend too much time worrying about uses for that right now. We probably won't even at all get into it in this class. But if you already know about modulus and you know how to use it, know that you can do it here in SQL, okay? Okay, so let's go and now get into the real reason we're here, which is the great and powerful clause, the where clause, okay? What I wanna do is show anybody that owes us more than $8,000, $7,000. Let's go 7. Okay, so where this right here is greater than or equal to, if you will, $7,000. These are the people that owe us the most money, and we want to get on them and say, where's our money? Okay? And there it is. We show these guys here, these 4 people that owe more than $7,000 right here, as you can see on the end there. Okay? And that's just, we can do math in our where clause, yeah.
Could we just use the alias?
You cannot, question was, can we use the alias here? And the answer is you cannot. If I do that, then you'll get an error. Yep, okay, good question though, because there are some places where you can use the alias, and we'll get to that a little bit later. All right, so let's put my semicolon in there. All right, so here we have this scenario where we want to not just do where some field is equal to something, but we're saying we want to do where some calculated value is equal to something or greater than equal to something. It's a totally legitimate way to do that, okay? Now, you can do greater than or equal to, just greater than, less than or equal to, and you can also do equal to, okay? Now, programmers, if you got a background in programming, that's not a thing in the database world, okay? That is, okay? So this means what that means in the programming world, okay? If you're not a programmer, ignore what I just said. Yeah.
Can you do equals exclamation point?
Do what?
Can you do equal exclamation point? So the-
You mean exclamation point equal?
Sorry.
Yep, and you can. Yes, I was getting there. Okay, so that's not equal to. You can also do this, which is what you're more used to, right? Not equal to, okay? If you're a Java programmer, that's got a whole different meaning in Java. That's with dealing with array lists and their generic classes, okay? Don't worry about that. In this world, it means not equal to, just like you're taught in grade school. This also means not equal to. Oops, that also means not equal to, okay? So those are all the comparisons you can do. We can also do multiple things in our where clause. So let's go back to what this looks like in the output here. Maybe I want all people who owe us $7,000, but they only have they have a smaller credit limit. Like this guy here. Somebody that owes me $7,000, but he's got a $15,000 credit limit I'm not too worried about. So maybe we want to just find people that have small credit limits and owe us a lot of money. So I'm going to change this to where it's greater than or equal to $5,000. And their credit limit, so I'm going to put this on a new line. And this is typically how I write my where clauses. And the credit limit is, say, less than $10,000. Okay? Whether or not this is a useful query is kind of irrelevant here. I just want to show you the possibilities. Okay, but this might be something that your supervisor might ask you to do. Okay? And so what this is showing me now, these are people that owe us a lot of money and they don't have a very good credit limit, right? So they're pushing up against their credit limit. So we want to either address increasing their credit limit or deal with, hey, where's our money? You guys are about tapped out here, okay? So this is a good use case for that, right? So that's a case where I'm adding to my where clause with just simply the word and. And I can do as many ands as I want. I could also do or, okay? So in the scenario of or, it means give me anybody that's got a credit limit minus balance of greater than or equal to 5,000 or a credit limit of less than 10. It'll give me if either one of those scenarios is met. I don't know if that's going to change the list in this case, and sure enough it does, okay? So in fact, it looks like everybody, there are 12. Yeah, that is everybody. So all 12 people fall into that category. So that's maybe not a useful query, but conceptually you can do that kind of thing, okay? So how are we feeling so far? We good? Okay. And I can do as many ands and as many ors as I want. Now, keep in mind that if I did something like or and then I did an and, whatever here, that's maybe not necessarily what you're looking for, okay? So here's what I mean by this. Let me see if I can come up with a good example here. Let me just look at the data for a second and come up with a good example. Okay, here we go. I got one. So what I want something like this, where I want this or this And I want, their balance, well, we already got that figured out. Okay, this is silly, but they're located in Fulton, okay? And city equals Fulton, okay? This query is not quite what I want it to be, because it's gonna do this, or this, and it's not clear. What do I mean? Do I mean these two, this and that? Or do I mean these two, and this? I mean, what exactly am I meaning here, right? So to be clear, you need to put parentheses around everything to clarify. And the parentheses work just like they do in math. You do that stuff first, right? So parentheses, I'm gonna bring this up on the same line for a little bit of clarity here. That. So I'm saying this or this, whatever that returns, and that this is the case, right? That make sense? So this is just basic logic, and here we go. We end up with these 3 records. Now again, I don't know if that's useful data, but I just want to show you how to tie those together, okay? All right, any questions about that basic idea? Okay. Let me check the notes here, see if there's anything I haven't covered yet that I want to cover. We got the concatenation, we got the aliases, we got the, all right, good, here's a couple more. All right, so now, if I wanted to, maybe I want to see everybody who has a $5,000 credit limit and a $7,500 credit limit. Just those 2 people. Okay, I want to see anybody that has one of those credit limits. Okay, I could do this, where credit limit is equal to 5,000, or credit limit is equal to 7,500. That works just fine, right? And that gives me these guys right here, 5 and 7. Well, now this table's only got 12 records, so I know that there's only 4 different credit limits that are in there. However, in the real world, this table might have millions of records. Who knows, okay? And so I don't know all the credit limits that are available to me. All right, so maybe the bosses want me to find out, give me a list of everybody who has exactly 5,000 credit limit, exactly 7,500, or they have exactly 99, which we know doesn't even exist in this database, or credit limit is equal to 1,000. That list could get pretty long, okay? So let's just run that, make sure you see that it does work. Okay, and it again found everybody that has either 5,000 or 7,500 or 99 or 1,000. Just so happens we don't have 99 or 1,000, so nothing showed up there. But there's an easier way to do that, okay? And that is by using the in command, okay? And I can do this, where credit limit is in this list, 5,000, 7,500, 99, 1,000, why not 100, whatever ones I want to put in there, okay? That's a lot easier than writing a whole bunch of or statements, right? And here we go. That gives us a list of everybody that's got either a 5 or a 7 or a 75 or 99 or 1,000 or 100 or 10,000, okay? Make sense? All right, there's one last one I want to show you, or 2 more. One is, this goes to Josh's question when the recorder was off a second ago. If I just wanted a range of stuff, maybe I wanted something between 5,000 and 7,500, 7,500, something like that. So what you could do is say where credit limit is greater than or equal to 5,000 and credit limit is less than or equal to 7,500, right? And that'll give me everything between there, okay? But there's actually a better way to do that even, okay? But everybody understand what that would return, right? Okay? Well, I can do this, where credit limit is between 5,000 and 7,500. And that gives you a range of what's in between that, okay? And it is inclusive, it'll include 5,000 and 7,500, okay? So there's a bunch of keywords there, right? So the important things to remember, let's just kind of sum this up here, and then I'm gonna show you one last thing, in the where clause, let's put a little note about the where clause down here. Where clause notes, okay? In the where clause, here are some keywords that you might use, and there's one we haven't talked about yet. We'll get to that in just a second. But you can do comparisons, right? So I can do, lowercase this. I can do comparisons by using standard stuff that you're used to, like less than, greater than, less than or equal to, greater than or equal to, not equal to, and another version of not equal to, okay? Those are standard comparisons that you're familiar with. And equal to. Just testing you. Okay, right. So all those are standard comparisons. Then we'll call those standard comparisons, okay? There's also, we'll call them other comparisons. And comparisons. And that is by using the keyword like, which we have not done yet. We'll do that in a second. Between, in, and one other one we haven't done yet called binary. Okay, we'll look at like and binary in just a second. Okay, we can also do logical operators. And those are what we just looked at, the and, the or, and there's also the not, okay? The only time you use not is when you're dealing with null, where you could say select star from whatever, where whatever field is not null, okay? Or is null, okay? And you can also do math. Which is plus, minus, divide, multiply, modulus. All right? So let's look at the like and the binary, and then we'll be done. The like is very simple in concept, right here. So I'm going to look for any stores that have the word gift in their name. That's what I'm looking for. All right? So my where clause is simply going to say where customer name is like gift. Let me explain what's happening here. So what's happening here, the percent symbol is much like the asterisk. If you've got a programming background, you're familiar with the asterisk, like a wild card that means everything. This is what this means. Give me every customer name that starts with literally anything. That's what the percent means. That starts with anything, and that anything could be nothing. It could be, it's literally anything to literally nothing, okay? That's what that means. Following that anything or nothing, it has the word gift. Following that gift, it has more anything or nothing, okay? So if I run that, it's going to give me all the stores that have gift in their name, and it's those three, all right? Let's narrow it down to ones that have gifts in their name, all right? There's no S there, okay? So we'll say gifts. That's going to narrow it down to those two. Now, in this particular case, both of those end with the word gifts, right? What if I wanted something that begins with the word gifts? In that scenario, I would do this. That means give me anything that starts with gifts followed by anything after it. Well, that's going to return nothing in our scenario, right? Okay. But I could also say, give me something that starts with anything and ends with gifts, okay? Now, in this case, coincidentally, it's the same data set as having something or nothing on either side of it. But you could, if you wanted to narrow that down specifically to only ending with gift, you could do that, okay? So it's going to give us those two. All right? Questions about that? Yeah?
What if you're looking for like cat or cats with an S? And
You want both?
Or you want,
Yeah.
one or the other.
Yeah, so in that case, I would do an or statement, right? I would say where customer name is like cat. Well, if you do that, that's going to give you cats. That will give you cats, right?
And also,
Well, no, yeah, that would give you cats. Because just like a minute ago, gift, right, that gave us gifts as well. See? Because it's the word gift followed by literally anything. Just so happens that the next thing it follows it was an S, right? All right, let me give you one last thing. I know we're out of time. It just take 2 seconds to do this. MySQL is not case sensitive. Unless you're on a Linux machine, then it's fishy, it's iffy, okay? So right now I could say select star, or we'll just go customer name from customer, where customer name is equal to unique gifts. Notice here that I wrote it in all caps, but it still returns it just fine. But what if I were looking for one that really was in all caps, okay? We can use the binary keyword, and I can say this. Select whatever from customer where binary customer name is equal to unique gifts. And now I get nothing, because there is no record that has full all caps. What that means is this. Take the binary value of what's in the field and compare it to the binary value that I'm putting right here, unique gifts. And the binary value of unique gifts, capital, is different from uppercase, lowercase, because we're dealing with the ASCII code and the raw, what does the machine actually see? And so if you were looking specifically where somebody capitalized something, you want to find that one record, that's a way to find it, okay? Any questions? All right, folks, I'll try to get this live tonight so you guys can go back and rewatch it if you want.